shut up. Nobody likes it. Anyway, so probability. When we talk about probability, we're talking about it like this. We usually talk about probability in terms of an event. The way we talk about a specific event, I'm going to start using this way of writing it out. It's more of a common way you'll see things. P of some event, it just means the probability of something that's going to occur. When I talk about the probability of an event, we're talking about the favorable outcome divided by total possible outcomes. So if you want to think of it really, really, really easy, if I want to say what's the probability, flip a coin and I get tails, it might be written like that. How many ways can you flip a coin and get tails? 1. How many possible outcomes are there if you flip a coin? 2. Therefore, the probability of flipping a coin and getting tails would be 3. I want to remind you that this does not equal that. I know they look very similar. Okay, just so we're on the same page. I'd like to see you try and get a coin to land on its side. No, I don't. I haven't had to use a coin in a phone thingy, payphone. I forgot what it's called, in 20 years. Thanks. That's what they're called. Probabilities of. You all right? Okay. I thought you were like blowing at the screen, going, messing my stuff up. Anyway, probability of an event occurring is always within the range of 1, 0. Probability will always be less than or equal to 1 or greater than or equal to 0. If a probability is equal to 1, oh, I thought you said never. I'm like, let's rephrase that. So the probability of an event occurring equaling 1 means it's gonna happen. If the probability of something is 0, it's not gonna happen. Yeah. Wah, wah, wah. So the probability of that occurring is 0. So the probability of I probably think you're wrong. You're on my right. Technically it is 50-50 because you either gonna. A lot of times what we do with probabilities, like I said, fractions or decimals, either one of them is fine. It doesn't matter. Your calculator does all the fraction mark stuff for you. You're going to simplify them out. The one thing that we look at a lot of times that people forget is, like, a really easy one is, what's the probability of rolling? Oh, I know. Let me just get the example up. I roll a 6 something. See, this textbook is nice. It's still old enough, whereas some of the newer textbooks, they say you roll a 6-sided number cube.
Yeah, right.
They do. They say that now instead of die or dice. Because yeah, they can. They'll say like an 8-sided die or whatever. But they don't use the word die or dice because then they start thinking about you're automatically implying gambling. Well, why wouldn't you? Anyway. Number 2. So if I want to, what would the probability of rolling a 4 be? Well, how many ways can you roll a 4 on a die? 1, and how many ways can the die land? I see what you're saying, the die lands, but how many possible outcomes of you think for making me rephrase that? You are right. So the way that the die could land would be 6. What's the probability of rolling an odd number? Well, how many odd numbers are on a 6-sided die? 3 of them, unless the 6-sided die had all 6 odd numbers. 4 odd numbers? That's weird. Anyway, so that would be 3 out of 6. Always, yeah. Good question here, guys. Anytime we have fractions or decimals of like this, we always simplify out our work because we never leave fractions unsimplified. Yes, ma'am. They're all being the same. If I go to percent here, I'd have to convert it. What's the point? A lot of times you'll see on I think it's more common to see the fraction form of these because it's like one less step that you have to do on like ACTs and all. I know that because I've seen those probabilities. They usually use fractions. And the last one, what's the probability of rolling less than 7? Does that mean you're rolling a 7? No. Could you roll a 7? No, but what numbers are less than 7 on a die? So the probability is. Well, we're talking about a normal 6-sided die, so we'll see how this works. So, all right, pick a number. I have a 6-sided die. How am I going to get a 7? I see a 4. Loser. What do you want? Loser. Devin, pick a number 1 through 6. Devin, that's not the numbers. The number is 1, 2, 3, 4, 5, or 6. Roll it. Yeah, he wins. Our admiration. Roll it again. Roll it again, Devin. Awesome. Hello. All right, once we get a drink of water, is that okay? I was thirsty. Now, things get weird. Now we start rolling 2. And when you have, if you're rolling 2 dice, or 2 dice, whatever, now you have to start thinking about the idea of possible outcomes. So we have 6 possible outcomes. You all right? All right. How many total possible outcomes are there then if you roll 2? 36. Because if you roll it doesn't matter if you roll a 4 and a 5, it's still going to add up to equal 9. So if I get a 5 and a 4, it still equals 9. So what happens a lot is that they're going to ask you with probabilities, they're going to talk about possible outcomes. So 2, 1. These numbers represent, on my first die I rolled a 1, the second one I rolled a 1. So these are 2 dice, these are the possible rolls. 1 and a 1, 1 and a 2, 1 and a 3, 1 and 4, and so on and so on. 3 and a 1, 3 and a 2, 3, 3. And there's a reason why I'm writing this out. I want to show you what happens. It's up to you. If you know the possibles, it's not a big deal. It's like doing your multiplication table. Oh boy. Now, a lot of times when you roll out 2 dice, the questions that they will do is they're going to ask you, what's the probability of rolling a sum? What that means is when you're adding the 2 values together. What is the most common sum that you can get when you roll 2 die? 7. Okay. The most common one would be your 7s. Close. Your most common is your 7s. No, that's close anyway. After that, the most commons would be sums of 8s. Okay. Oh yeah, I'm sorry, 6s. Sorry, I'm going the wrong way. I was thinking, 6 and 8s. So if you ever go through and played Monopoly, the most common stuff, or the stuff that you want to buy, is anything that starts from the origin on 7s. Okay, your 7s; those are going to be the most frequently hit values. Every 7, because it's the most common one. Out of the rolling 2 die, how many ways can you roll a 7? 6. So 1/6 of the time you should be landing on a common 7. You might also get the question here, well, what's the probability of a sum that is greater than 10? If I want to know what the probability is of getting a sum greater than 10, well, how many ways can I roll greater than a 10? Well, if I roll a 10, is it greater than 10? No. I have to roll 11 or a 12. How many different ways can you roll an 11 or a 12? 3 of them. I can roll a 6 and a 5, a 5 and a 6, or a 6 and a 6. There's only 3 possible outcomes out of 36. And again, use the fraction bar in the calculator, and then it'll simplify it out for you to 1/12. Is this vaguely ringing a bell of things that you've seen in the past? I didn't. So far, earlier today, it wasn't that big of a deal either. I think most people figured that out. Do you know the difference between theoretical versus experimental probabilities? It's R-E, isn't it? Reticle, is it a K? Whatever. Hey, just so you guys know, the degree that I got says math, and then the other ones I have say curriculum and instruction and technology. It never in there said spelling. I'm serious. Anyway, so I'm joking if you have a spelling degree or know somebody that does. Theoretical theoretical versus experimental. What's the difference? Exactly. You guys have probably done that before. Anyway, the theoretical probability of Maggie picking out the one card. The theoretical probability of Maggie guessing the correct card was what out of what? 1 out of 52. The experimental one of getting that happening was 1. It happened. Well, the first time she got it on her first try, so it was 100% right. She should have just quit while she was ahead. I did, because that's what I do. The second, then she lost, and then we realized that, it was 1 out of 2, and then it was 1 out of 3, and so on and so on and so on. So what happens with this theoretical versus experimental is that in theory, you flip a coin 100 times, you should get 50 heads, 50 tails. But yet, if you flip it 100 times, you can only get 60 and 40. You can get 51, 49. 99. Wait, you can get 99 1. We'll talk about probabilities of how that could happen because there is ways of figuring it out. So there are ways of figuring that out in those strings like that. But just wanted, I know you've probably seen that. I just wanted to make sure I spoke of it really quick before we got too far. And you probably did it in chemistry or one science class at some point, some silly experiment. Is it chemistry? Yield's a good album too. No, yield is just like when you're a virgin. You yield right away. Anywho, so yeah, it's easy. And then you get to do this. Geometric probability. You did this last year. The geometric probability is when you're talking about the probability of a certain thing occurring. For example, you can, you might not, I don't know. Up to you. Let's say you wanted to find the probability of landing in the bullseye. Yeah, I like that. See, Devin, we bring bow and arrows to the high school because we're cool like that.
This is why we go on walkdown.
I'm not gonna kill anybody. So,
Famous last words.
so what's the probability? You alright? Feel nervous? She's just laughing like So the probability of getting bullseye is what? 0. Oh. 1 out of 6. Oh. So you got to figure out the what is the area of the bullseye? 3. Well, that's the radius. So what's the area? Seriously? Yes, because pi's are round. So 3 squared is. There you go. Yes. All right. So, and then you have to do that over the total area, which would have been what's the radius of the entire thing? 144 pi. You can't. All right, ready? I've learned that using a crossbow version is easier. You guys didn't realize you were like in the splash zone.
No. I wouldn't consider that the splash zone, but.
Oh. All right, here we go. Oh yeah. All right. Hey, way to go, Devin!
I don't like that.
Well, it's supposed to be making sounds. It's not making sounds.
Is it that E? Just do this for the rest of the class.
Okay, Maggie. I need help.
You always do it the wrong way. I don't think you can do it from that angle.
You're right. Well, it's not like this is the most incredibly awesome thing ever made. I don't know. I'm sad. I'm getting there.
Take the entire class for you to get a bullseye.
Oh, come on!
Is that you? Joking.
Not sure it's serious.
I was joking.
Hey, stop playing with the heroin. Specimen. This might be on its last legs.
No, maybe you're on your left.
So I may or may not steal one of my children's Nerf guns and try it. Maybe it might work better. They've got the darts at 6, so I'm thinking one of those.
I did all of your hits.
The wall. At least the probability of me hitting the wall was pretty good.
Yeah.
But yeah, no, when I first made this, the first I'll ask about this. When we first made this one up like this. The older style smartboard. I think Devin, your smartboard it's got pressure to it, or is it a hardboard like that? Sure. The old boards down at Huntley when we were at the high school there, if you make a fist and you touch the meat of your thumb, you kind of push in on it a little bit. So you can actually push to it. It's kind of how you tell if a steak's done, also how good it is, depending on how far you know. Anyway, the older boards, when you touched it, it knew where your stylus stuff was at. And when that bow and arrow thing hit it right here, sound effects went off, and it knew where it was right away. Or if it hit here, it would boo you because it missed. But now with the newer ones, it's a little bit more difficult. I don't know if you guys ever came up to the board and looked. There's 4 little small cameras in the corners, and they math to figure out where your location is at. So when the projectile, my super awesome bow, when it hits the board, whatever. So when it hits the board, So far, I haven't hit anybody today. Don't jump up. You guys are like. Anyway, or if you really want to get crazy, hey Shipkey. The arrow. Get it? You see it? I'm joking, Shipkey. No, I'm not. There's a good chance I'd miss the wall completely anyway. This is why I don't go hunting with a bow and arrow or really anything because I would miss. Yeah, so good times. Um, yeah, yeah, that's really all I got. So, did I post the numbers on the home already? I think I did. Already saw that one? Oh, rainfall over total. So if we go back to actually talking about what we were doing besides just horsing around. If I wanted to land in the bullseye has an area of 9 pi. The total area would have been 3/4. This was 12, so 144 pi. Throw it in your calculator and go. Percent? Okay. Now, if I wanted to find the probability of just landing in orange, if I wanted to find the probability of landing in the orange, I have these three regions I'd have to deal with. So you have to find the area of each of those regions to do that. You guys remember how to do the donut hole problem? You don't have to do it that. You don't have to do it that way because if you go this and you do the outer region, the outer one has a radius of what? Is it 9? Everybody okay with that? So then I would subtract the inner part. So I have 9 squared, and then subtract out 7. So is it 81 subtract 81 minus 9? Peace out, Devin. Is that what 32? So the first orange ring would be at 32 pi. I do that again with this one would be 36 subtract 16. And I have a 9 pi. So my total possible orange region would have been 52 and 9, which is 61. It would have been 61 pi over that total area of 144 pi. And throw out the calculator with the fraction bar and do that. And you don't have to give me percents. You can just give me decimals if you want for those. Or if it simplifies the fraction, that's fine as well. It's really okay. Any one of those is fine. I would say steer away from the percents so that we don't accidentally move the decimal the wrong way because it's easy to make a dumb mistake. Okay. Does that make sense, Shipkey? I know you guys have seen it. I just kind of got sidetracked by sound effects. It's like the last one. And then you had, I think is that Pac-Man? All right. And then, yeah, Frog. That's Frog. You guys know what Frogger is? It's just somebody yelling "boo." And then, C. Yelling. What did I say? 12 through 34. It shouldn't take very long. I had a couple kids just usually come in for flex. They just do their homework. They got it done in like 15 minutes. It's really quick. Okay. We'll add more to this stuff tomorrow in the half thing. I don't know how many of you guys are actually here because of the movie stuff, but we will be working. I'll record it. I actually think I figured out what's true now.
I got it. Well, it's not working.
And hey, throw away your trash. Jeez. Kids these days leaving their junk laying around. Questions? What do you have? 15 dice? You're going to roll like a 63. Otherwise, usually it's just online paper. I was close with my 60. Are you playing Yahtzee?